Hello everyone, how are you all? I hope you all are doing very good. In today's class, we are going to study completely about plane mirror. Plane mirror? What is there to study that much in plane mirror? Yes, there is so much to study about plane mirror. What are those? First, in today's class, I'll give a glimpse of what we are going to study in today's class. First, we are going to study basics of plane mirror and reflection, right? And afterwards we are going to study ray diagram of image formation by plane mirror with measurements. Afterwards we are going to study characteristics of image formed by plane mirror, and afterwards we are going to study what is angle of deviation, what is the basic introduction of angle of deviation, and what is the derivation of formula for angle of deviation, and how the angle of deviation varies with the angle of incidence. And after that we are also going to study about the what is the focal length of plane mirror. We know that the spherical mirrors have focal length, right? Does this plane mirror also has some focal length? If it has, what is the focal length? If it has focal length, there must be some power also. So what is the power of a plane mirror? And also we are going to study about, we know that V is equal to U in plane mirror, but why is that V is equal to U in plane mirror? We are going to study that also. And is sign convention applicable for plane mirror? Yes. How? We are going to study that also. And at the end we will study about what is the magnification of the image produced by a plane mirror. These are all the things we are going to study about plane mirror in today's class. So without any delay, let us start today's class. Okay. So first let us study what is reflection and what is angle of incidence, what is angle of reflection, and in this also what is there sir here to study. We know already what are laws of reflection, what is angle of incidence, what is angle of reflection. You will find something new in this also. Okay, try to concentrate. First, what is a mirror? You know already. So we represent a mirror like this. This one will be the glass, and the small lines which are there, this represents the opaque coating present behind the glass. Generally student will forget or will neglect these small lines, but it is very important to draw those lines also. Okay, so let us take this as a mirror, and after taking mirror, this one will be the incident light ray. Light ray comes and falls upon the mirror. This is the point of incidence. This is the light ray coming towards the mirror. So this one will be point of incidence. Exactly at point of incidence we are going to draw a perpendicular line to the mirror. So now this one will be the angle of incidence. Angle of incidence I. This is the incident ray, this is the angle of incidence, and this one will be the point of incidence. Okay. So now after, suppose this is 30 degrees, with the same angle of reflection, the reflected light ray will go back. How to draw this diagram perfectly? I'll definitely explain to you how to draw the image formation diagram. This one will be angle of reflection. So this one will be normal n dash, and this one will be reflected light ray, and this one will be angle of reflection, this one will be angle of incidence, and this one will be incident light ray. Okay, until here everybody knows what is this angle here. Is there any name for that angle? Yes, there is a name for that angle also. That angle is called as glancing angle. Glancing angle. What is this angle here? This angle is also called as glancing angle. Okay, so how a problem can be asked on this is, they'll give angle of incidence and they'll ask you to find the glancing angle. So let us mention this as glancing angle, angle G. This is also angle G and this is also angle G. What do you need to understand? You need to understand that angle of incidence plus glancing angle. See, some formulas will come here. Angle of incidence plus angle of glancing will become is equal to 90 degrees. And also, if you look at this one, this side, angle of reflection plus glancing angle. Angle of reflection plus glancing angle also will result into 90 degrees. And you know already from laws of reflection that angle of incidence will be is equal to angle of reflection, correct? So angle of incidence will be is equal to angle of reflection. So now how they'll ask you questions on this. Suppose they give angle of incidence. Imagine that they have given the angle of incidence, right? They gave angle of incidence is equal to 30 degrees and they ask you to find angle of glancing. What will be it? 90 minus 30, that will be is equal to 60 degrees. How did we get this one? From this. Angle I plus angle G is equal to 90 degrees. If you want to find angle G, send angle I this side. It becomes 90 minus angle I. Angle I is 30 degrees. So it is 60 degrees. Like that, they may give angle of reflection and they may ask you to find angle of glancing, or else they may ask you to find, they may give you glancing angle, they may ask you to find out the angle of incidence. Like that, however they may frame the question, you should be able to solve, right? So this is about the basics of plane mirror and reflection. Laws of reflection. What are laws of reflection? First law states, always remember the first law states, what first law states? The incident ray, reflected ray and normal, they all lie on the same plane at a point of incidence. This one will be the point of incidence and all these three lie on the same plane at a point of incidence. That one will be first law. What is second law? Second law is angle of incidence will be is equal to angle of reflection, right? So now let us go towards the formation of image by a plane mirror. The best way to draw the image formation by plane mirror. So first take a straight line of length 6 centimeters. Of length 6 centimeters and exactly at 3 centimeters mark a point, and perpendicular to it you mark two more points 3 centimeters above, 3 centimeters below. This point is going to be our object, this point is going to be our image. So now again from this point 2 centimeters this side one point you mark and 2 centimeters this side one more point you mark, right? So now 2 centimeters 2 centimeters here. So this is going to be the point of incidence. These 2 points are going to be the point of incidence. From here you take one light ray like this, and from here you take one more light ray like this. So now again the reflected light ray should start from this point. You know, right? The point where the reflected light rays will meet, that is called as an image. So from this point the reflected light rays should go back, and that too from this point to this point it should be dotted, and from here again thick lines. So now we got the ray diagrams. Here we have to draw the normal, and here one more normal. This completes the ray diagram. Now these two are incident light rays. So mark the light rays direction. This is incident light ray, this is another incident light ray. This is one reflected light ray, this is another reflected light ray. And this is going to be the angle of incidence, and this is going to be the angle of reflection. This is going to be the angle of incidence I, and this is going to be the angle of reflection R. Now this point which is given here, this point will be the object. Okay, this point will be object. This this will be the reflected light ray. and this point will be our image, and this will be our incident light ray. Okay. Now coming to the characteristics of image formed by the plane mirror. This image, if you see, the reflected light rays are not originally meeting. If the two reflected light rays are not originally meeting, we call the image as virtual image. Image will be virtual image, and the object distance from here to here, the object distance will be equal to image distance. Image distance is equal to object distance. And object height will be equal to image height. Object height equal to image height. And the most important property will be image will be laterally inverted. These are the characteristics of image formed by plane mirror. Some more things also we can mention, like object distance and image distance. This one will be the object distance u, and this one will be the image distance v. U and v. Now let us study about the angle of deviation. See, first let us study about the angle of deviation. Angle of deviation. What is this angle of deviation? Imagine that you are going in this direction. Okay. First, imagine that you are going in this direction. Okay. At this point, you took a turn like this. Okay. Initially, you are moving in this direction. You took turn in this direction. So you got deviated from here to here. Correct? So this is the angle formed between your original direction and the present direction. This is known as angle of deviation. Angle of deviation lambda. You got deviated. This was your original direction. You got changed the direction and you were moving in this direction. How much angle did you deviate? This is the angle you got deviated. Correct? So in the plane mirror reflection also, there is an angle of deviation. Where will we find the angle of deviation in plane mirror reflection? See, once I'll explain to you. Let us take a plane mirror first. Okay. So if we take a plane mirror, suppose imagine that a light ray comes like this. Okay. If a light ray comes like this, then this one will be the point of incidence, and this one will be the normal, and this one will be the reflected ray. Correct? So now initially light ray is going in this direction. Correct? Light ray is going, this was the direction of light ray initially. But now it got changed the direction and it is moving in the direction now. See, this was the initial direction of you and this is the direction in which you are moving. The angle formed in between these two is angle of deviation. So this is the initial direction of light ray and this is the direction in which the light ray is passing after reflection. So this one will be the angle of deviation. Here what is formed? This is angle of deviation. So now this one will be angle of incidence and this one will be angle of reflection, angle R, and this one will be glancing angle, angle G, and this angle is angle of deviation. This angle of deviation is represented by this symbol lambda. Angle lambda. Now, how to define this angle of deviation? The definition of angle of deviation goes like this. See, what is the angle of deviation definition? Angle formed between the extended incident ray and the reflected ray. Extended incident ray and the reflected ray is called angle of deviation. Is called angle of deviation. How to derive a formula for angle of deviation? There is a formula to derive for angle of deviation. So now if you look at just only single, if there is a straight line, imagine this straight line is there, right? This is a straight line. We are going to use some part of geometry here. Suppose I draw a straight line here. What will be the total angle formed from here to here? The total angle formed here will be 180 degrees, correct? So now if you look at from here to here, total angle it will be how much? 180 degrees, correct? That 180 degrees is comprising of angle I, angle R plus angle of deviation. See, this is straight line, right? This straight line from here to here, how much angle should be there? It should be equal to 180 degrees. That 180 degrees is having angle I, angle R and angle of deviation. So can I write angle I plus angle R plus angle of deviation? If I add all these three, how much angle it should be resulting into? It should be resulting into 180 degrees, correct? So this equation we can take now. If I take that equation, what am I going to get? I am going to get as angle I plus angle R plus angle of deviation is equal to 180 degrees. We know that I is equal to R from laws of reflection. So we can write I plus lambda is equal to 180 degrees. I plus I, 2I. 2I goes that side. So it becomes 2I plus lambda is equal to 180 degrees. So lambda is equal to 180 minus 2I. This is the formula for angle of deviation. Sir, I is equal to R. Why do I need to replace R with I? I'll replace I with R. Then here and here R plus R, 2R. 2R goes that side, it becomes 180 minus 2R. So lambda is equal to 180 minus 2R. So these are the two formulas for angle of deviation. Now, how this angle of deviation will vary with respect to angle of incidence? Now, by looking at here only we can explain if angle of incidence increases. See, so imagine that I is equal to 20 degrees. Then what is the angle of deviation? It is 180 minus 2 into I is 20 degrees, correct? So how much we are going to get? 180, 20 into 2. 180 minus 20 into 2, 40. It is going to be 180 minus 40, 140 degrees. I will increase the angle of incidence now. Suppose angle of incidence is equal to 30 degrees. Then what happens to angle of deviation? Angle of deviation is 180 minus 2 into I is 30 degrees. 2 into 30, 60, correct? 180 minus 60. 180 minus 60, 120. So if you increase the angle of incidence, angle of deviation is going to decrease. Okay. Now, next what shall we study? We shall study some problems on angle of deviation. Before going to study some problems on angle of deviation, you should be knowing how a light ray will reflect. You know that if this is a mirror, If light ray comes like this, what happens? Here angle of incidence is formed, correct? And with this is angle of incidence, and with the same angle of reflection, the reflected light ray will go back, correct? Okay. Now, what happens? Suppose the mirror is like this, okay, and light ray came like this. What is the angle of incidence here? Angle of incidence here will be is equal to 0 degrees. Why? Because what is this angle? This angle is formed between the normal and the incident ray. In this case, where is the normal? Normal is also here lying along the incident ray. When normal is also lying along the incident ray, where is the angle there? Angle is itself 0. So angle of incidence is equal to 0 degrees and it reflects back in the same direction. So angle R also will be equal to 0 degrees. So when light ray comes perpendicular to the mirror, angle of incidence is 0 degrees, angle of reflection is also 0 degrees. So how it comes? Like that only it goes back. Okay. So this is about the theory of the angle of deviation. Now let us solve some problems on this angle of deviation. First problem. Angle of incidence made by a light ray on a plane mirror is 30 degrees. What is the angle of deviation? What is the angle of deviation formula? Angle of deviation formula is 180 minus 2i. So lambda is equal to 180 minus 2 into 30 degrees. So 2 into 30, 60. 180 minus 60, 120 degrees. Okay. So now they gave angle of incidence. Angle of incidence they gave. Okay. And they asked us to find the angle of deviation. Now let us take one more question. The angle made by reflected light ray with the plane mirror is 65 degrees. Angle made by a reflected light ray with the plane mirror means which angle they have given? See, observe neatly. I'll explain here. Angle made by reflected light ray with the plane mirror. This angle they have given. Okay. Is how much they give? 65 degrees. What is this angle? This angle is nothing but the glancing angle. Correct? So read the question neatly. Angle made by the reflected light ray with the plane mirror is 65 degrees. Find the angle of deviation. So what they gave? They gave angle of glancing. Glancing angle is equal to 65 degrees. If this is 65, how much will be this? Total this one will be 90 degrees. Correct? So if 65 here means how much will be R? R will be is equal to 35 degrees. If R is equal to 35, what will be I? I alpha will be equal to 35 degrees. So glancing angle G is equal to 65 degrees, which implies angle of incidence I is equal to 35 degrees. Now we have to find angle of deviation. What is angle of deviation formula? Angle of deviation is equal to 180 minus 2i. So it is going to be 180 minus 2 into I is 35. 2 into 35, 70. So 180 minus 70. 180 minus 70 is 110 degrees. So this one will be the angle of deviation for this question. Next question. The angle of deviation suffered by a light ray is 40 degrees. Find the angle of incidence. Means they gave the angle of deviation itself, lambda is equal to 40 degrees. We have to find angle of incidence I. What is the formula? Formula is lambda is equal to 180 minus 2i. Okay, lambda they give 40. 40 is equal to 180 minus 2i. Minus 2i comes this side, plus 2i. 40 goes that side, minus 40. So 2i is equal to 180 minus 40. 180 minus 40, it is 140. So I is equal to 140 divided by 2. So I is equal to 70 degrees. Okay. So this is about the next problem. Let us take the next question now. Find the angle of deviation for the light ray as shown below. Here, how the light ray will come? The light ray will come like this. Suppose the light ray is like this. This is the light ray. Incident light ray is coming like this. Okay. Then reflected light ray is like this. What is basic of angle of deviation? See, what is the basic of angle of deviation? We have to extend the incident light ray. Then we have to find the angle between reflected light ray and the extended incident light ray. So where is incident light ray here? Incident light ray is here, like this. This is the extended incident light ray. And where is reflected light ray? Reflected light ray is here. So what is the angle present here? Angle present here is 180 degrees. So the angle of deviation in this case, it will be is equal to 180 degrees. Now next question comes, what is the focal length of a plane mirror? What is the focal length of a plane mirror? See, if you imagine a spherical mirror, any kind of spherical mirror if you imagine, either it may be a concave mirror or it may be a convex mirror, how the mirror will be? The mirror will be like this, correct? Imagine this is the center of curvature. First, let us take a straight line as principal axis first. Now, I will take this point as center of curvature. Now, with this center of curvature, with this much radius, I will draw a sphere. Okay, so this one will be a mirror having this much radius of curvature. I will increase the radius of curvature now. So this is another mirror having the larger radius of curvature. If I increase still radius of curvature, what happens? This one will be another mirror, correct? Now, if I still increase the radius of curvature, this will be the mirror. Maximum if I increase, see what is happening here. If I increase the radius of curvature of a spherical mirror, it is approaching close to the plane. See this one, if you say, is it not looking like close to plane mirror? If I still increase, then it will come at the end like this, close to plane. Close to plane it will come. Yes or no? Like this, close to plane. So what is the radius of curvature of a plane mirror? If we increase the radius to infinity, then we will get a plane mirror. Okay. So now, or else we can explain the same question as, if this is a spherical mirror, you take a very small part. This is a spherical mirror, right? If you take a very small part, this is looking like a plane mirror only. How much small part you have to take? Very, very infinitely small part if you take, it will be working as a plane mirror only. Or else if you increase the radius of curvature to infinity, then also it will be working as a plane mirror. So what is the radius of curvature of a plane mirror? Infinity. If radius of curvature is infinity, what will be the focal length? Focal length also will be is equal to infinity. So what is the focal length of plane mirror? Plane mirror has focal length, and that focal length is infinity. So now, if it has focal length, it should be having some power also, correct? So focal length we got F is equal to infinity meters. Then what is power? Power formula is P is equal to 1 by F. So power P is equal to 1 by infinity. 1 by infinity is 0. So power of a plane mirror is 0 diopter. Power of a plane mirror is 0 diopter. Next, how this object distance is equal to image distance in plane mirror. Okay, so now we know the mirror formula. Mirror formula is 1 by F is equal to 1 by V plus 1 by U. Just now we found out focal length of plane mirror. It is equal to infinity. 1 by infinity is equal to 1 by v plus 1 by u. 1 by infinity is 0. So 0 is equal to 1 by v plus 1 by u. You send this 1 by u this side. It becomes minus 1 by u is equal to 1 by v. If you cross multiply, it is going to be v is equal to minus u or u is equal to minus v. So this is how v is equal to u in plane mirror. Okay. So now next, is sign convention applicable on plane mirror? Yes, sign convention is applicable on plane mirror also. If you have a plane mirror like this, and you have an object here, this one will be the object distance, correct? This one will be the object distance, and somewhere here image will be formed, correct? Image will be formed here. Just now we studied object distance and image distance and image formation by plane mirror. Apply sign convention here. Take Cartesian sign convention. See, object is placed left side, so object distance will be is equal to negative and image distance v will be positive. Okay, that's why we will get u is equal to minus v here, or v is equal to minus u here. Okay, in the v is equal to u. Next, what is the magnification produced by a plane mirror? What is magnification formula? Magnification formula is m is equal to minus v by u in mirrors, correct? So now we just now got v is equal to minus u, correct? So instead of v, I'll write minus u. So m is equal to minus of minus u divided by u. U cancels, minus into minus plus. So magnification m is equal to plus 1. So this is about the magnification of plane mirror, and everything that can be asked about plane mirror is covered in this video. I hope you learned nicely and you are learning every day from our channel. Thank you so much. Keep learning. All the very best.